Hello everyone, welcome to this video. My name is Amir Ahrari. I'm a Google Earth Engine expert. Today I'm going to show you how we can collect wind speed data from Google Earth Engine platform. It's a very simple tutorial and also you can use it for all around the world. Let's go to the Google Earth Engine. So first of all, the first step, we need to identify the region of the interest through the drawing tools available here. For example, I'm gonna select a part of my own country, Iran, same as other tutorials I have published in my YouTube page. Through the rectangle tools available here, I select a part of central part of my own country, and then to have focus on the study area, use map.center object. Map.center object enables you to have focus on your study area when you run the code. For example, when I run the code, map.center object helps to have focus in our study area. So, in the next step, we need to find wind speed datasets through the search places and dataset available here. Browse data catalog first and then explore your desired data based on considered tags. As I mentioned in the previous YouTube tutorials that I have published in my own page. Through the filter dataset tags, you can find your desired data. For example, in this tutorial, we're gonna use wind speed data, and if you write wind, 18 datasets available for now. Go to the wind tags and you can see several products available here, and also their name, explanation, visualization, everything is available here. And also you should consider that, and also you need to know that some of these products not only designed for the wind analysis. For example, one of the most popular products is ERA 5 products. For example, ERA 5 daily aggregates available since 1979 with 27,000 square meter, 27,000 meter spatial resolution. And you can see that many bands available here. One for total precipitation, one of them for the temperature, one, for example, related to the surface pressure, and there are two bands such as U component and V component. Actually, the U and V here showing the direction of the wind speed. U showing or referring to the wind speed directions from east to west or vice versa, and also V component showing north-south or vice versa wind speed regarding to the direction that they have. And as you can see in such products, if you want to get a single value for the wind speed, we need to apply a single equation in the Google Earth Engine platform to get a final wind speed with combination of U and V components together. So now I'm going to show you how we can combine these two type of products, these two type of wind speeds with different directions into the Google Earth Engine and get the final wind speed without any attention to their direction. Back to the code, but before that we need to copy the collection ID from data catalog and paste it into the search places and dataset. As you can see, ERA 5 daily aggregates available here, imported into the code, and then make a new variable, for example, wind equals to, or first we can set a general name such as ERA 5 without any attention to the available bands, equals to image collections. Here we are assigning image collection to ERA 5 as a variable, and then as this is a daily product with high temporal frequency and also long extent period available since 1979, we need to set a period of time to download the data. For example, if you want to download data for 10 years or for 15 years, we can use one variable, because for each year we have 365 images, and for 10 years finally we will have 3,600 images at all. And also, as far as the total images are less than 5,000 image, we can download them very easily without further problem. And also I will show you how we can download the wind speed data or the daily data for the longer period of time. So first of all, I'm gonna show you how we can download for example wind speed for 10 years, and then I will show you how we can extend it for a longer period of time, because we need to change something in our code. So no need to set any filter bound. .filter date is necessary, because this is a coarse spatial resolution and doesn't have any framing structure such as Landsat or Sentinel. The filter date here could be, for example, from 2000 to 2024. I want to call and get or collect all wind speed images, or I want to get the average of wind speed for this region. So, and for the next step, as we have two different bands, U component and V component, in the next variable, I will write an equation showing you how we can combine these two bands together to get the final wind speed without any attention to the direction. So now print error 5 to see that how many satellite data available for this period of time. So it's very awesome. In the Google Earth Engine platform, by very simple script, you can see that more than 3,000 satellite data collected. And also imagine that you wanted to download 3,000 images, and also it was very difficult process without having access to Google Earth Engine platform or something like that. And it is true that in Python programming language you can write some script to download write some script for the batch download data as a list, but however it is a little difficult compared to what we are doing in the Earth Engine platform. Everything is ready in Earth Engine. Scripts are ready, and data catalog is ready, and platform is ready. You don't need to install anything, and also it's very, very simple and easy to use. That is very important. So back to the code. Each element, as you can see, couple of bands are available. And as I mentioned earlier, for example, one band showing the total precipitation, one of them surface pressure, but we only need U component and V component. Throw the here dot select help us to select specific bands. I want to select those of bands starting with U, and the rest of them is not important, and starting with V, and the rest of them, the rest of letters, not important. So again, run the code, image is under calculation, and as you can see here, each element including two images, one of them U component of wind, and the next one is V component of wind with 10 wind speed for the 10 meters. Actually the wind speed here estimated based on 10-meter distance from the Earth's surface. So that's why we say that this is wind speed in 10-meter elevation from the Earth's surface. So in the next part, make a new variable that is wind speed equals to, here in wind speed variable I want to get error 5 data from the previous variable and then throw a map. I'm gonna make a loop in which each of the available images imported and for the calculation of the wind speed. Here we need a function to do a single process on each available element. The function input image renamed or considered as an img here, and now I want to write an equation equals to from each input image, that is including two bands u component and v component, that expression, I want to calculate this equation. The equation is first is qrt, first parenthesis, plus the second parenthesis. The first parenthesis including u power of 2, the u component to the power of 2, and the second one v to power of 2 to the power of 2, as you can see. So this is a simple equation that helping us to get the wind speed by combination of v and u component. In some of the wind speed products, u component and v component not available, and also just you have a single wind speed value. But for such kind of products that including v and u components or v wind speed by these two variables, we need to use such equations to get the final value for the wind speed by considering the east, west, or north source directions. So, and now for each unknown variables in the equation, that here is u and v, we need to identify u belongs to u component and v belongs to v component. So make a parenthesis, and here the first unknown parameter in the equation, or term in the equation, is u equals to from input image, it is belongs to that band starting with u, that is u component. The rest is not important. So, and the second unknown parameter v, it belongs to img from each input image dot select v component, do that band is starting with v, and the rest of them, it's not available, it's not important for us. And finally, we want to rename the new band as wind speed. Remember that at the end of each function, we need to return the final result. That here is the equation that we calculated. And with this equation band or the wind speed band, we need to copy the properties of input images, specifically system time start and system time end. That are really important for the further processing in the Earth engine. So now we have wind speed data, and to test it, first we can use a print wind speed to see that the calculation from syntax point of view is right or not. Yes, there is no syntax problem in the wind speed variable and the function that is created. And for each date, you will see that there is one band showing the wind speed value. So, and now I want to get the average of wind speed for this region from 2010 to 2024. That is the simplest part of this tutorial. And most of you know about the user interface .chart.image. User interface chart image .series, helping you here to show the variation of the average wind speed for this region. Instead of image collection, we need wind speed image collection, and the region should be geometry, and the reducer should be replaced by the average. Reducer.mean, Earth engine dot reducer.mean. That is very important argument here. The scale should be 27,000 meter because the spatial resolution is 27 kilometer. And X property should be system time start because this X property is that property that helping us to see the variation over the time and explaining the time. Among all properties available here, the only thing that help us to do time series analysis and help us to have date information is the time start because the acquisition date for each product is stored in the system time start. So system time start here. And again, run the code. Chart is under generating. After chart is generated, you will see the daily variation of the wind speed according to the equation that combine the U and V components. If you had any problem regarding to this tutorial, you can check your code with mine because I put this tutorial code in the description part of this video, same as the other tutorials I have published in my YouTube page. And now you can see that the wind speed with the daily temporal frequency is calculated, and it ranges from 1 meter per second to 6 meter per second for this region of my own country. And sometimes you can see that most of the time it ranges from, for example, 2 and 3, between 2 and 3, and sometimes it goes above 3 meter per square, 3 meter per second. And then through the download CSV, you can have access to the CSV format for the further processing if you need it. So that's the simplest way to get the wind speed data for your region of the interest. But one important question is, if we wanted to get the wind speed since 1979 to 2024, what should we do? For example, we know that the Earth engine is sensitive to 5,000 elements processing, and we cannot plot, have such kind of plot for the daily data over 40 years because more than 5,000 elements interrupted and also caused negative errors in the calculations. So to solve this problem, we can use some alternative method in the Google Earth Engine platform, and we have to use some sort of complicated code to solve such kind of problems. So now I want to show you how we can get download wind speed data for more than 5,000 variables. So now I want to make a new variable. The new variable is wind 40, meaning that I want to get daily wind speed for the 40 years, equals to, from the image collection, the input collection is ERA5 daily aggregate, and as you can see in the descriptions, it's available since 1979. And now I want to use this variable for all the wind speed data that are available since 1980 to 2020. Actually, here we have 40 years period, long-term data analysis we want to do. And so here I want to know that how many images are available for this period of time. Use print for wind 40, and here in the panel in the right side, you can see that the calculation aborted because we are accumulating over 5,000 elements. That's the problem we have. But if you use the size, you can see that how many elements are available for this period. More than 14,000 images over this period is available. So now I want to show you a simple technique in Earth Engine, and also with a little more programming step that helping you to download more than 5,000 images for your region of interest. So now make a new function to get the date and get the average value of wind speed for your region of interest without printing results. So the function means here, for example, I call this function get value. This is a function that goes through the collection properties and collect the date information and collect the average value, and also then we can download it as a feature collection in the Earth Engine. That is very simple. I will show you how to do that. So this function have a one argument that is input images. The input image will be wind 40. And now in the body, make two variables. The first variable is the date. I want to get the date information from each input data. So here, for example, Earth Engine dot date, I want to get from each input image, Earth Engine dot image. From each input image, I want to get the date information, img dot get system time start. As I mentioned earlier, system time start is a properties including the date acquisition for each available images. And when we use Earth Engine dot date, helping us to convert system time start from, for example, millisecond format to the year, month, and day format. So to do this completely, you should use .format, and .slice. .format and slice here helping you to consider the date or millisecond date as a string value, and then by .slice I want to select from first letter, for example, or first number to the letter number 10, for example, in the string we selected. So, and also for these numbers from 0 to 10, I want to consider it as a string, or I want to get it as a string and convert it to the date format by Earth Engine .date function. So for next, I want to get the average value for this region by reduce region. So the next one is value equals to the input image. I want to consider it as an image from input image that reduce region. Reduce region. Some arguments are necessary. For example, the first and the most is a reducer, Earth Engine reducer mean. For the geometry we are studying, and based on the scale we are working 27 kilometer or 27,000 meter. To have the final value as a number, write that values, and we want to get it from the first item, that get first item or first band, that get 0. We want to get the average of wind speed for the region, and we want to have access to that as a values from the first band, that get 0. The band number 1 equals to band number 0 here. So, and Earth Engine number, helping to ensure that we are working with a number as a result here. And finally, the function returning the date and value together. Date and value. Here I'm going to make a list of date and each value. The value is the average wind speed. So for the next part, we need to calculate the same equation, wind speed function. As you can see here, we already calculated wind speed by this equation, but this time I want to use this for the period from 1980 to 2020 for 40 years. And here we need to replace era 5 with wind 40, and here you can see that the equation is done, and also we don't have any problem for calculations here. Just we face problem for more than 5,000 elements when we want to do visualization process, when we want to print the results. So, and for calculation, no problem occurred. You can process millions of elements in the Earth engine, but just we encounter a problem when we want to print more than 5,000 elements. So, or we want to download them as an image or something like that. So, for the next step, make a new variable as a size. Here we want to make a CSV format. We want to make a table with CSV format, and also in this table we need some records. To identify the number of records in this table, we need size variable that should be equals to the number of the elements that available in the wind speed variable. Wind speed 40 is the target variable here. Wind speed 40 dot size, and dot size showing that how many images are available, because we want to make a list based on available images. Print size. In the right panel, you can see the size equals to 14,610. So for the next, I want to make a list for apply the function on each available images. So here, make a new variable, wind list, for example. So here, wind speed 40, get it, and then import it into a list through the to list, and the list size already defined by size variable, and then through the dot map we want to apply get value on each available images. So in the next step, for example, if we print the result, now we have a list with two columns. The first is date and the second one is the average value for wind. So if you want to check it, and also because I want to show it quickly without time consuming process, I just reduce the temporal date or temporal extent to 1 year, just to show you how the code works, and at the end I will run the code for the 40 years. So print wind list. You can see that a list is under computing. Here we have 366 elements, because I have reduced the temporal extent from 40 to 1 year, just to show you how the code works. And here, as you can see, we have a list with two columns. The first column is date, and the second column is the related wind speed values that calculated for each date. So for the next step, we need to convert the list from the list format to a feature collection format, because through a feature collection format we can get the output with CSV format. So make a new variable, for example wind feature equals to get wind list. First we need to define Earth engine feature collection here. Earth Engine.feature collection. Inside we have wind list, and then throw a map. I want to set a name for each column under feature collection structure. So .map, make a new function. Each input row in this function, consider it as elements here, and the elements should be converted to a list format. That's why we need to write EL, or input argument, equals to Earth Engine dot list elements. So finally, the function returning feature. So this feature should have a geometry and properties. No need to geometry, leave it null, and then for the properties, write the name of each column and also set the color ID to each name. For example, the first column is date, starting with date, equals to Earth Engine.string. From the input element, get the first column. So, and the second column, for example, is wind speed, and equals to Earth Engine.string. From the input element, get value number 1, that is equals to second column. So just like that. And finally, print wind feature to see that how many features now available. Now we are converting the list including date and wind speed to the feature format. Why? Because we want to get export with CSV file. So here we have a feature collection, and also we have a date, system index, and wind speed. And for each feature is available, you can see that with two properties. One of the properties is date and the other one is wind speed. Now we can get export from Earth Engine with CSV format. Just write export. This time use .table, not image, because we want to get export from one image collection, not an image stack or something, or image collection or something like that. .table to drive, because we want to have the output in the Google Drive. So the collection or the feature that we want to extract, that we want to download, is wind feature, and the description, the name of the output could be, for example, wind speed for 9081 to 9082. And the file format, another argument that is very important here, the file format here should be CSV file. So save your code and run it again. In the right side, the task highlighted, we have wind speed CSV data. Click on run, and you can see this. After click on run, the process of saving in Google Drive started, and also we need to wait until the saving process ended, and also when the panel color turned to the blue, meaning that it is ready to download from the Google Drive. So, and you can use, now we can use this code for the longer period of time, for example from 9080, and also you can see that the wind speed is ready and done. Here in the Google Drive, I can show you the informations that available in this data. You can see that there are system index, data, wind speed, and the geo. Geo is related to the location. You can remove this column, and also you only need to the wind speed and the data. The rest of column should be removed when you download and import it into the Excel or Python for the further programming. So now I want to use this code for a longer period of time, from 9080 to 2020, for example, for 40 years. Just let me to change the names for the description. Windows speed 40. Run the code, and now we have a Windows speed data for 40 years. Click on run, and now we need to wait until the process is done. The process of saving in the Google Drive is done. If you had any problem regarding to this programming step, because it's a little difficult, maybe for the beginners to write this script, you can use the ready to use code that I have put it under the video description in my YouTube page, and also you can use it and compare it with your own code to solve your issues. But again, if the problem didn't solve, you can reach me out through my YouTube channel and put your comments. I will check and help you to solve them. So now, as you can see, after 3 minutes, the process of saving is over, and now through opening Drive, you can have access to the CSV file in the Google Drive. Just right click and download it. And now you will have access to the daily data, daily Windows speed data since 1980 to 2020. And it is based on CSV is available, and I'm gonna open it up in the desktop software to show you for each day or every day the wind speed for 10 meters above from Earth's surface is ready to use for the further processing. So as you can see, this is daily values, and also this is the wind speed column, but we don't need to the system index and also the geo. And you can remove the extra columns through the delete options, delete column available here. And also if you are working in the Excel, it is also available. It is also possible to remove the extra columns by the removing process, just like that. It's very simple. And as you can see here, yes, just like that. And again, save it with the CSV format and use it for the further processing.